is very simple. When you look at big data algorithms, you look from the perspective of convolutional neural networks, or neural networks which or deep learning. But I'd like to reiterate, all the algorithms that you use in traditional machine learning or in data mining can be used for big data. That means even today in the industry, cosine similarity is extremely popular because it is very fast. K nearest neighbor is extremely popular. Navy Bayesian algorithm is extremely popular. Only difference here is the data. You use some framework where there is parallelization. Maybe you talk with respect to Hadoop framework and things like that. But here the focus is not on the Hadoop framework, which is more onto the infrastructure management. The focus is more on the machine learning part of it. Though there will be a lot of claims that convolutional neural network, deep learning networks, various name, AlexNet, Google's own net, and things like that. You need not worry about it at all. You need not worry about it at all as long as you have the fundamentals strong. So it is the fundamentals that is going to be extremely critical when you look from the machine learning perspective. Now, how does big data analytics differ from your typical machine learning algorithm is something which we'll try to understand and see how to take it forward. Let me share my screen. Time to say bandwidth, maybe I'm offline. My blank screen is visible, right? Okay. Is my blank screen visible?
Yes, sir, visible, sir.
Thank you. See, basically when we talk of your typical machine learning or data mining algorithms, we were talking with respect to a data set which may contain about 1 million records or about 10 lakh records. Now, when you have this 10 lakh records, maybe I use it for training, I use it for testing. But the most important part is big data talks about two things. The first scenario is where the data is continuously streaming into the database. The second scenario is the number of records is huge. I'm talking of, more than 10 million or something. So I have huge data and the data is coming in continuously. Now, in big data, you look at it from multiple perspectives. One is the architect, the framework in which the data is going to be analyzed. In that case, I might have a database. Which can accept data dynamically. I might have an algorithm like your map and reduce, which is capable of splitting the data across multiple virtual machines. The moment I talk about multiple virtual machines, I am basically talking of a cloud architecture. So it can be map and reduce. Okay, that means what is it I'm trying to do? I'm trying to break down the data, do a horizontal split. When I'm talking of my database, it is huge. I do multiple horizontal split and I share this data to multiple virtual systems. Okay, other than that, there is going to be no major changes. So I can, here what happens is, let us say I'm working on the feature selection algorithm. I want to select the features. So I have my virtual machine, which is going to have a small amount of records. Instead of the original 10 million, maybe I have only 2 million records. Now, using this 2 million records, which can be considered as a sample, 2 million is huge. So we need not worry that there will be a statistical difference with the data, with the other data. So in this 2 million records, I can do what, my first step could be the feature selection. So maybe what I'll do is I can use filter based technique, or I'll use a wrapper based technique. All the existing algorithms can be used. So if I'm trying to use MRMR, it can be used. If I'm trying to use correlation based feature selection, it can be used. If I'm using a chi-square test, it can be used. Any of these techniques can be used. And the feature selected. Now the beauty here is I have multiple records. So now what I can do is I have multiple methods of selecting the feature selection. So let us say I'm using information gain. I am using information gain in virtual machine 1, information gain in virtual machine 2, information gain in virtual machine 3. Each of this technique now will start processing the data. Each of this technique will start processing the data. So when I say processing the data, maybe let us say there are about 300 features. Now the first virtual machine is using IG. It may select about say 40 features. My second virtual machine may also select say about 36 features. My third virtual machine may select about say 45 features. So I have 3 machines which is analyzing the entire data. Each machine is working independently, assuming that 2 million or 3 million records is the records with which is the entire scope of the records. Now what is happening is each of the machine, I am applying very simple information gain technique, filter based technique to select the features. Now let us assume my system has selected 40, 36 and 45 features. You can be pretty sure that about 30 features will remain the same. So this 30 features will be common to all these 3 information gain methods used on different data. So the moment I talk of 30 features which is common, then I may talk about 6 plus 30 is common. So I have 10 features in the 40, I have 6 features in the 36, and 15 features in the 45. So now I have about 31 features which is not common to all. In this case, what I can do is I can write my own simple algorithm where M1, M2, M3. I'll say what all is common between M1 and M2. Select common between M1, M2, then M1, M3, M2, M3. So let us say that means I am looking at a duplex wherever the feature is occurring twice. Let us say there are about 6 or 7 features here. Let us say there are about 4 features here. Then I add this to the total features selected. So I have 34 features. So in effect, if you are using VCA or if you are using a traditional data mining algorithm, what you would have seen is you would have seen it in a small database. Whereas when I run it across multiple, I know the number of features selected, I can write a simple logic and select the optimal features. So what does it mean? Any algorithm which can work for a machine learning, a typical data mining algorithm can also be ported to big data algorithms. Only difference is going to be is I get multiple outputs. What is the rule to process this multiple output is the $1 million question, which we try to resolve as a data analyst of or a big data specialist. Did you get this? So it can be information gain, it can be any filter based technique, it can be chi-square, it can be information gain, it can be MRMR, mutual information. Any technique can be used. Only thing is, since I split the data in parallel and I run the algorithm independently, so that it selects independent features based on the data that it has. And after that, I consolidate it by writing a very simple algorithm. I given you the simplest algorithm. where all the common features are selected, and I say these are the common features. Then all the duals, if it is occurring in machine 1 and machine 2, machine 1 and machine 3, or machine 2 and machine 3, those features I take, I consolidate this and say this is the best features. Okay, so here what we are seeing is a machine learning technique which can be used for feature selection. Any questions here? Anybody has questions? No, very simple. So no, there is no rocket technology between machine learning and big data analytics. The only place where you need to really worry about is whether you want to work on the Hadoop framework to process the data, or do you want to work in the area of the machine learning overall architecture, so that you select the features, give the features, the machine and you select the best features, then you feed it to the classification or clustering algorithm, and the outcome of the classification algorithm is what you interpret. Okay, so this is one very simple use case of big data algorithms in real life. Okay, so what happens is my information gain or mutual information which is running independently has to consolidate, and when the consolidation is happening, I can do whatever I want. I can think of doing whatever I want. I can say I want to my screen is visible, right?
No, sir.
No, okay, let me reshare that. So ultimately what I am trying to do is, I am trying to use my existing algorithm. I am trying to write a wrapper over it, stating the rules as how do I select the features. So I have my containers, my 3 individual systems, and each runs its own feature selection algorithm, maybe IG. Then I write a method to this madness. How do I consolidate all these 3 things? The moment I consolidate and get the data set, I will say that I've used big data techniques to find the ideal features. But honestly speaking, what you are seeing, it is nothing but your basic technique which is running on 3 independent machines in parallel for different data. Got it? Any doubts here? I hope you don't have any doubts. The same can be also applied for classifiers. So my feature is selected. Now, I can either consolidate all the data together. I can consolidate all the data together to create a master database. And in this master database, I can use any of the algorithms. I can use KNN, I can use Navy Base, I can use support vector machine, I can use ANN, I can use decision trees. I can use decision trees. I can use any of this algorithm. There's one scientific way to the madness of obtaining the correct technique where we are using existing algorithms. Alternatively, you might state, I don't want to break my head on all the technology. I'll directly go for deep learning techniques. In that case, I can think of using a convolutional neural network. I can think of using a recurrent neural network. What will this do? Though they are in separate containers, you'll have a wrapper. The same wrapper that you saw in IG, information gain, the same wrapper will be there. But the only problem is, the data, we do not worry about processing the data much. So, though it may look very great, though Amazon or Microsoft or Google will talk about convolutional neural networks where they show you training images and then testing it. But the method what we are talking of is what is actually being used in the industry. Reason being very simple. I have my algorithm which is very rugged. I can use algorithms which are extremely rugged. I need not go for deep learning networks which require a large amount of processing space. But no processing power, processing space, all these complexities are avoided. Okay, so there are no special algorithms except for the framework. So the moment I talk about framework, we talk of Apache Spark as one popular framework. We also talk about using Hadoop framework. But now both of these are not critical as such. No, you can always try splitting this and taking it forward on your own using your typical Python code. Okay, so using Apache Spark, I can use PySpark instead of using Apache Spark, or even if PySpark is going to be a challenge, I can still use my pandas library or my numpy library and ensure that the data is processed. Okay, so only thing that we really need to worry is the computational complexity of each algorithm. As long as the computational complexity of each algorithm is linear in nature, you need not worry. But the moment you talk of convolutional neural network, or if you're talking of parameter tuning of the convolutional neural network, then you're going to have a big challenge. The challenge is not only on the parameter tuning, which is called as hyperparameter tuning. The challenge is also on the execution time. The computational complexity is going to be way higher. So you again follow the keep it simple stupid formula. Keep it as simple as possible. See, my argument or the premise of my entire argument is very simple. You have data. This data can be analyzed using the simplest of the algorithms like KNN, use filter-based techniques for feature selection. I use the simplest algorithm. I see the performance. If the performance is extremely poor, then I can also understand that something is wrong in my data. So I need to go back to my data. I need to see whether my data follows a normal distribution. If it is not doing it, should I apply a non-parametric test? And typically there are two types of tests. One is called as a parametric test, where you make an assumption. We make an assumption that the distribution is normal. The moment we make an assumption, we assume that skewness is 0, mean equals median equals mode equals 0. Mean equals median equals mode, and skewness is 0. But in real life, this will never happen. Your data is going to be skewed. So it is going to be skewed between -3 to +3. I'll just assume that it follows the normal distribution and use parametric test. But in spite of all this, if I am still not able to decrease my skewness value, then I need to go for a non-parametric test. Non-parametric test is something where no assumptions are made. Parametric tests are something where you make assumptions. Okay, so the easiest way to not to get confused here is take a small sample. So if I have 10 crore records, take 1 lakh sample. You can happily work in your laptop. Call it as a sample. Take 5 samples. Use your typical machine learning algorithms. See the performance. And if you feel that everything in the data is clear and the performance is extremely good, then deploy the entire population if required, so that you'll be able to afford the computational space also. Got it? I'll just represent my screen. Is my screen visible now?
Sir, no, sir.
No, okay.
எப்படி கொடுத்துட்டு எப்படி கனெக்ட் பண்ணிட்டீங்க? இது கனெக்ட் பண்றதா நீங்க வச்சிருக்கீங்க
நமக்கு
Is my screen visible now?
Yes, sir. Now it is visible.
Okay, thank you. So I'll get into the next important topic where in the previous session I was talking about various techniques for analyzing the data. One next important technique that we need to really understand is the normalization of data. So this is something which helps you a lot in the, when your machine is learning. Now let us take a simple example. I have one variable which is called as age. I have a second variable which is called as income. If you look between the age and the income, there is a huge gap. Okay, the machine will see 20 as a small value, whereas it will see 20,000 as a large value. Okay, so given a specific age, if I do not know the range of the age, it becomes very difficult to state where is the location of that specific age. So if the age is between 20 to 60, and if I say my age is 21, then the location of the age is on the extreme left, or it is almost close to 20, where I can state 21 is almost equal to 20, or you are a young guy. Whereas if a person is 59 years, we can see that he is closer to 60, and we can say no, you are a old guy. But benchmarking this becomes a challenge. No, if I'm talking of salary 20,000 to 80,000, I honestly don't know. And 20 and 20,000, the difference, or the age 25 and salary 23,000 the difference looks very huge, but not really so. So to overcome this, the z-score was introduced. It tries to get you a value between -3 to +3. Typically you get between -1 to 1. But you can get any values between -3 or even greater than that. -3 to +3 is something which definitely happens. How do I calculate this? What is the advantage calculating it? How do I calculate it? And how do I interpret the z-score is what we'll try to understand. The z-score is given by x minus mu by sigma. So the moment I see mu, I know it is for the population. This can also be done for the sample. So I have age here, I have the mean age, I have the standard deviation. Understand again, when I say standard deviation of +3 SD, 33 plus 34, 67. 67 is going to be the upper limit. So I found the mean, I found the standard deviation. Now I can apply this formula. 26 minus mean is 34.1 divided by standard deviation, which is 11.64. So I'll get a value which is -0.7. Okay, I got a value of -0.7. I'm calculating the same for all. What are you able to draw any inference from this? A negative value, positive value, any inference? What do you mean if it is a negative value? Can somebody think and tell me what does it mean that it is a negative value? Look at the data. Looking at this 4 data, what is it you derive? Anybody can guess? Why is it negative value, and what is it you derive from this? நல்லா பாருங்க, மீன் வேல்யூவோட கம்மியா இருந்துச்சுன்னா you get a negative z-score. If the age is below 34.1, then you get a negative z-score. Look at the cases. 26 is less than 24, 34. 20 is less than 34. Then you see 22 is less than 34. 34 and 20 are less than 34.1. So now 34 and 34.1 almost close to 0. So here one thing we can understand is if the z-score is negative, my value falls below the average value. Now, if this is the data, if I don't want to share my data, let us say I am from Swiggy or I am from Amazon or Myntra, I don't want to share my data, in which case I can try showing the z-score values. It's not impossible to work backward. It is possible, but I'm making it difficult. So I can share the z-score values. Once I share the z-score values, it becomes extremely easy. When I am trying to analyze the data, I can very easily identify if the value is negative, then I know that the value is below the mean value. Well, that is the first inference that you make. Second is we never leave the uniform distribution. So now in the uniform distribution, we had discussed that the standard deviation will be -3 to +3 typically, but you'll have a lot of random values coming in. But most of the data will be between -3 to +3. You can also see the percentile, or you can look at the z-score. Z-score -3 also is the same as the standard deviation, almost similar. But if you look at the standard deviation here, it expands, whereas z-score converges faster. Right? So z-score also will be able to tell me if the value of the z-score is between -3 to +3. I can confidently state that it follows a normal distribution. Got it? Sorry. Now, when we have z-scores, when you see the value here, when you see the value, whatever value you see here, let us say I'm looking at 1.45. What it does is, it represents the area under the curve. It represents the area under the curve. So, if this is if this is 0, if this is 0, sorry, this is 0.5, this is 1 and this is 0. I'm normalizing the data. All the values here are less than 0.5. All the values on the right side is greater than 0.5. So if I have a value here, I can do the plot. If I have a value here, I can do the plot. I can do a marker, find the x and y value. Okay, now this represents the area under the curve. This is called as the area under the curve. So the moment I see a value like 0.42, the moment I see a value like 0.42 and it is positive, it means that the z-score is towards the right of the mean. Any terms here, very straightforward. What all can we do using the z-score is the next challenge that we need to address. So this is called as a standard normal table. Whenever you Google and take this data, be extremely careful as what is shaded. Here you are seeing the shaded towards the right of the mean. That means if I normalize the data, this value will be 0.5. Below the mean, you have a value of 0.5. On the right side of the mean, again, you have 0.5. So the sum of the area is going to be 1 after you normalize it. Now, how do you read this table? We'll understand it. Let us say I have a value minus 0.42. I see the value minus 0.42 here. Now, how do I take it forward? There are two tables. I'm seeing one more table which is colored differently. Now, how do I interpret the data and how do I take the data forward is the challenge that we need to address. Here, what it tells is it is covering the entire area. It is covering the entire area. Whereas here, it is covering the entire area which is not of interest. So, since the total area is about 1, if I want to find the value of B, using this table, then it is going to be 1 minus C. Because I'm getting the C value, I'll call it as 1 minus C. Whereas, if you look at this particular graph, if you look at this, it is above the mean. So I need to add 0.5 to it because anything below the mean has a score of 0.5. So to understand this better, let us take an example. I have 0.25. I have the value 0.25. I'll come to this table. 0.25 falls here. If it was 0.25 falls here, proportion in body is 0.5987, or I'll write it as 0.5987. Look at this 0.5987. If my graph, if my table contains like this, it means it is only showing above the mean, which is equivalent to the D, proportion between mean and Z. So it is going to be 0.0987. But if you add 0.5 to it, it will become 0.5987. Clear? Now, what does this indicate? So I know that 0.5987. So what was the data we took? We took the data minus 0.25, right? We took this data 0.25 and I got the value. What is the value I got? 0.5987 or 0.6. I got this. For this, I got a value of 0.5987 or 0.6. Multiply this by 100. The moment I multiply this by 100, I get it as 60%. Okay, what the interpretation is, there are 60% records which have a lower age than my age. So my age is 37 and my z-score value computed from the standard normal table is 0.5987. Even if you use this also, you will see that I have 0.5. I don't have 0.59. I have 0.5, 0.9. But it was 0.5987. Here it is only 0.59. Since it is, this displays the above the mean, I'll add 0.5 to it. So I'll get a value of 0.7549, which is close. Okay, what it indicates is there are records which are 60% below me. Is that true? We'll find out. Here this was computed for the age 37. How many values are below 37? 1, 2, 3, 4, 5, 6. Right? I got the value as 60.6, right? 0.5987. I'm able to show that 60% of records are lower than or equal to my variable or my value. Any questions here? Any doubts here? It may look deceptively simple. If you have not understood, please ask me again. Anybody has doubt? It may look deceptively simple, and afternoon session you'll all feel sleepy, but no other go. Anybody has doubts in this? Understanding the z-score table. If you are able to understand the use of the z-score table, then adapting to t-score or any of the chi-square becomes extremely easy. So we saw how to represent or how to normalize the data using z-score. And we also saw the advantages of using z-score. We also saw the advantage of using z-score tables in understanding the location of the data. Now, as a data scientist, the first area that you need to really work, even if you're doing research, is to work on the sample rather than the population. So the moment I talk about sampling, how do I pick the samples is a challenge and research area by itself. Some of the common techniques are simple random sampling, systematic random sampling, stratified random sampling, cluster sampling. In simple random sampling, a sample is selected very randomly. Okay, so I have 100 fruits in a bag, I have 100 oranges in a bag, I randomly pick one orange. That is a classic case of simple random sampling. Or if I want to pick 5 oranges, I'll dip my hand into the bag, pick the first orange, then I will dip the hand into the bag again, pick the second orange, and hence so forth. I'll pick 5 oranges. This is a classic example of simple random sample. The next method is called as the systematic random sampling. In systematic random sampling is what I'll do is I'll try to find a method to the madness. So if I'm talking of the marks obtained by each student in the class, I have mark 1, mark 2, mark 3, mark 1, mark 2, mark 3. I'm putting it in ascending order or descending order, highest to lowest. Now, I might state I will take sample every second sample. That means my second sample will be selected, fourth will be selected, sixth will be selected, eighth will be selected. Got it? So here what happens is I either put it in ascending order or descending order in some method to the madness. I arrange it in a specific way, then take every kth sample. Now if I want 10 samples and there are only 20 records, then every alternate sample has to be picked up. If I want 10 samples and there are 100 records, every 10 sample has to be picked up. Simple logic. Then we have something called as stratified random sampling. In stratified random sampling, I form subgroups. All the girls become one group, all the boys will become one group, all the girls who are above 5 feet 5 inches will become one group, all below 5 feet less than or equal to 5 feet 5 inches will become another group. The same will apply to men. So I am forming small groups. So once I finish this into groups, from each group I'll do a round robin and pick the samples. So this will ensure that your data, that your sampling follows the population. Then I have cluster sampling. Cluster sampling is very useful when you are looking at geographic boundary. That is the reason why our COVID Sputnik 5 tested in Russia was not accepted in India, because the cluster or the geographic boundary that was created was within Russia. We did not have Indians, or they did not have Indians. Indians were not there. The sampling had to be, the testing has to be carried out again in India. So cluster sampling is based on pin code. I can say based on pin code, I'll select people. So each pin code will form a sample. And from each of this, I'll prepare, using a round robin method, I'll select one sample every time. Any doubts till now? Anybody has doubts? No doubts? Okay. Now, the next important thing that we try to really understand before getting into big data machine learning algorithms are finding the finding the variance between two parameters, or finding the relationship between two variables. How do I find it? Okay, so one of the most popular concept is the covariance. Covariance tries to find out what is the impact of one sample with respect to the second sample. So I can give you an example: cigarette smoking and lung capacity. So you will easily understand that as the cigarette smoking increases, the lung capacity decreases. So I smoke more cigarettes, my lung capacity decreases. Okay. Now I want you to have a look at this data. And can you tell me, is this interval data, ratio data, or is it ordinal data or categorical data? Somebody can pitch in. Don't worry about making mistakes. So I showed you in the screen the lung capacity, number of cigarettes smoked versus the lung capacity. I'd like to understand what is the type of data. Don't worry about making mistakes. Karpagapriya? What is the type of data? Let me reiterate, if you are not able to understand this, it becomes extremely difficult. So I have something called as N. N is nothing, it is not an important data at all. It is nothing but the numerical value. No, it's a unique ID given to each person. So this, how I interpret is, there are of the people who went to the hospital, 45 claim, of the people who went to the hospital, whenever a person does not smoke cigarettes, he has a lung capacity of 45. Whenever a person smokes between 1 to 5 cigarettes, his lung capacity is 42. Similarly, the moment it increases to 6 to 10 cigarettes a day, the lung capacity falls down non-linearly from 42 to 33. If the person smokes between 10 to 15 cigarettes, then the lung capacity further comes down to 31. If the person smokes more than 20 cigarettes, lung capacity is about 29. Looking at this data, or if you look at this figure, first I want to understand whether this is an interval data or a ratio data. Is this an interval data or ratio data? Don't worry even if you're making mistakes. Interval data or ratio data? Or is it categorical data? Or is it ordinal data? Anybody wants to make a guess? This has to be an interval data. Cigarette smoking is a ratio data. Cigarette smoking is a ratio data. Whereas lung capacity is a interval data. Why do I call lung capacity as interval data? Because it does not have a true zero. If the lung capacity becomes zero, that means the patient is dead. The patient is dead. That is what I am trying to tell. Whereas if a person is a non-smoker, it becomes a 0 cigarettes. So cigarette is a ratio data, lung capacity is a interval data. Looking at this graph, you can make 2-3 good assumptions. This can be converted into a categorical data if required. So for making that into a categorical data, I might say if a person smokes less than 5 cigarettes a day, I'll call him as a non-smoker. If he smokes between 5 to 10 cigarettes a day, I'll call him as an occasional smoker. The moment he smokes more than 10 cigarettes a day, I'll call him a hardcore smoker. Got it? So I've basically converted my linear data into a categorical data or a ordinal data. If I wanted it as a categorical data, then I'll say smoker, no smoker, period. But no, I can do that. But the challenge is, if you look at the data here, this is what makes it challenging, because up to 5 cigarettes there is no income. There is no change in the lung capacity. Statistically, the significance is extremely low. So I can very honestly state, if a person is smoking less than 5 cigarettes a day, the lung capacity is not varying at all. So I can say if a person is smoking less than 5 cigarettes a day, I'll call him as a non-smoker. Anybody smoking greater than 5 cigarettes a day, I'll call him a smoker. So classic case where I converted a category, discrete data into my categorical data. Okay. Here, if you see, the variables co-vary inversely. When the number of cigarettes increase, the lung capacity decreases. So we say that they are inversely proportional, or as one candidate goes up, the other candidate comes down. Got this? Now I can see that and I can understand it, but now let me do a mathematical way of finding it. So we use the covariance formula. The covariance is given by 1 divided by n minus 1 multiplied by summation of xi minus x bar into yi minus y bar. What is x? The number of cigarettes smoked. What is y? The lung capacity. So I have my formula something like this. I can do the computation. I'm doing the computation for xi minus x bar. Okay, so first I need to do xi minus x bar. What is the x bar here? 5 plus 10, 15 plus 30, 50. 50 divided by 5 is 10. No, 5 is 10. So the mean is 10. Xi minus x bar is 0 minus 10 is minus 10, 5 minus 10 is minus 5, 10 minus 10 is 0. The same logic I apply for yi minus y bar, which is nothing but the lung capacity. So I can do the computation. Xi minus x bar into yi minus y bar is minus 215, and I get a value of minus 53.75. Since I got a negative value, I can very confidently state that when the value of one parameter increases, the value of the second parameter decreases. So they co-vary negatively. One important parameter from the correlation coefficient is the Pearson's correlation coefficient. If the data is normal distribution, if the data is non-normal distribution, then I use a Spearman's rank correlation. What Pearson's correlation coefficient tries to do is, it computes the z-score, and once the z-score is computed, the correlation coefficient is found for the computed z-score. So converting that into a formula is summation of xy minus summation of x summation of y, where x is the number of cigarettes, y is the lung capacity, divided by square root of n multiplied by summation of x squared minus of summation of x whole squared. Let us try to understand this. I have X, I have Y. So I have, let us say I have 2, 3, then I have 4, I get 6. Now, summation of X is given by 2 plus 4, 6. Summation of Y is given by 9. Okay, then XY, I multiply XY, which is 2 multiplied by 3, which is 6. Then 4 multiplied by 6, which is 24. Here what I am trying to tell is summation of xy, this is xy, 2 into 3, 4 into 6. Summation of that is 6 plus 24, which is 30, minus of summation x multiplied by summation y. What is summation x? Summation x is here, summation y is here. So 6 into 9, which is nothing but 54. What is the number of records? There are 2 records. So 2 multiplied by 60, 30 minus 54. So I get 6 in the numerator, divide it, summation of x squared. Okay, summation of x squared is, summation of x is 36. 6 squared is 36. 36 multiplied by 2 is 72. Minus summation of x whole square. Sorry, I am doing the other way around. Summation of x squared is 4, here it is 16. So summation of x squared is n into, that is 2 into summation of x squared. X squared is 4 plus 16, which is 20. So 2 into 20 is 40 minus summation of x whole squared. Summation of x is 36. 6 whole squared is 36. 40 minus 36 is 4. So I get a value 4 here. I substitute all these values. That is what I have done here. So I am calculating summation of x. Summation, no, I am doing x squared and doing the summation of x squared. This is my summation of x squared. Then I am doing xy, y squared. Okay. Of course, no, number of cigarettes smoked and the number capacity of the life is the same. I am doing x squared, xy, y squared. I am finding the summation of it. I am applying the formula. When I apply the formula, I get a value of minus 0.9615. Interpretation of this correlation function is extremely critical. Interpretation of the correlation function is extremely critical. Pearson's correlation coefficient will always have a value of -1 to +1. -1 to +1. What does that mean? Let us try to understand. Okay, now first we'll understand the negative value and the positive value. Let us say in a hill station, whenever the temperature decreases, the consumption of coffee increases, the consumption of cool drink decreases. And maybe if biscuit is also there, the consumption of biscuit is not affected by the climate. The second scenario is when the temperature increases, consumption of cool drink increases and the consumption of coffee decreases. So whenever temperature increases, whenever temperature increases, whenever the temperature increases, consumption of coffee decreases, consumption of cool drink increases. There is no difference in the consumption of biscuits. Then we'll state temperature and coffee are inversely correlated or negatively correlated. Because when temperature is increasing, coffee consumption is decreasing. Similarly, we can say consumption or temperature and consumption of cool drink are positively correlated. But there is no difference between temperature and biscuit because no person just eats biscuit. Kulura irundhalum biscuit saapran, kulura illanalum biscuit saapran. So we'll say Temperature and biscuits are independent. Temperature and biscuits are independent. Now comes the formula, and the critical thing. We are able to compute the correlation coefficient, but how do I interpret it? I can give you a formula for this. If the value is between minus 0.4 to plus 0.4, plus 0.4, then we state the variables, both the variables are highly independent. If it is lying between minus 0.4 to minus 0.7 or plus 0.4 to plus 0.7, then we state they are weakly correlated. If the value is greater than 0.7, or less than minus 0.7, then we say they are negatively correlated. So getting this value of minus 0.9615 is not important. Understanding and utilizing the correlation in your research or in using it in big data analysis is what is important. Okay, so if in the independent variables, if there is strong correlation between two variables, then we can happily remove one of the variable. We can eliminate one of the variable without any problems. If you eliminate the variable, then the algorithm computational complexity also comes down. The algorithm also performs better. Any questions here? Any questions here on correlation coefficient? So correlation coefficient becomes a parameter for selecting continuous, to identify two interval or ratio or continuous data to find the correlation between these two. If they are strongly correlated, either positively or negatively, then I eliminate one of the record. If both are independent variables and we are trying to predict a dependent variable. Alternatively, if they are independent or no, they are weakly dependent. If they are independent, I do not have a problem at all. So whatever I showed you is called as correlation based feature selection. It is called as correlation based feature selection. And whatever I have showed you, I can show it as independent, which is not a problem to me at all. If it is independent, I am very happy. If they are dependent, two independent variables are dependent, I eliminate one of the variable, again I'm happy. But if both the variables are weakly dependent, I have a problem. No machine can talk about it. This is where I set the parameters. Let us say I have a value of 0.62. I can take a decision stating, here look, it is 0.62. No, my rule states 0.7 is, no, they are greater than 0.7, they are independent. They are dependent. So no, since it is 0.62, I will make a hypothesis. I'll tell a null hypothesis wherein very clearly I state that the correlation will assume any value greater than 0.6 or less than minus 0.6. We'll say they are strongly correlated and eliminate one of the features. I'll have to document this. As I do the research, if my hypothesis is proved, if my hypothesis is rejected, I am very happy. If it is not rejected, but the null hypothesis is accepted, I need to go back to my drawing board. So big data analysis is not about pulling a data, putting it into a machine. It is all about taking a sample, analyzing the sample, using simple techniques to identify what is what are the parameters how is the data behaving, how is the data behaving, how is the classifier performing, how is my feature selection techniques, where I look at the chi-square value or the correlation based value. Chi-square is applicable for categorical data, whereas for continuous or discrete data I apply this thing. I apply your Pearson's correlation coefficient. If the data is normal, not non-normal, that means the data for the variable, if the skewness is greater than is something like 15 or something, I'll not use the Pearson's correlation coefficient, I'll use the Spearman correlation coefficient. So in Python, for when you're writing a code for big data and you're using Python, you will use a command called as COER. COER represents correlation. The default value of the correlation, default value of the function is Pearson's correlation. But if the data is non-normal, you need to go for Spearman correlation. In that case, you need to give COER in brackets, single quotes, you will have to say Spearman. If you don't do this, you are making a mistake at the elementary stage itself. So the entire idea, what I am trying to draw a parallel, or what I'm trying to say is, there is no major difference when it comes to algorithms between big data and your regular data. Work with the sample. If you are happy with the sample, then go for the big data techniques. Normally, typically, you look at deep learning techniques unless you want to be a solutions architect, in which case, you are talking of using tools like Hadoop. Any questions? Anybody has questions? No questions. Okay. So now let me also look. Now let us get into a little bit of how algorithms work. So when we talk about big data algorithms, somebody has a question. When we talk about big data algorithms, as I rightly told you, as I very specifically told you, whatever algorithms we are using in machine learning has to be adapted slightly. Okay, so based on the map and reduce, you need to identify the number of virtual machines and run individual algorithms there. So now what we'll try to do is, let us try to understand how some of the algorithms work. Maybe I'll take a screen. I hope you are all able to follow. Since all are silent, I'm not able to judge. But I'm trying to teach it in the most simplest way so that you can understand it. Let me share my screen. The k-nearest neighbor algorithm works on a very simple principle. You're able to see my screen, right?
Sir.
Okay, thank you. See, k-nearest algorithm works on a very simple principle. Okay, now let us try to see how it works. You generally look at it from the solution space. Now let us say in my hotel, let us say I have a hotel. In my hotel, I am trying to measure what people eat in the morning. I try to measure what is it that people eat in the morning. So I might have the first person coming in. He takes 2 idli, 1 vada. Problem in my pen. He takes 1 vada. The second person comes, he takes 3 idlis, then he does not eat any vada. The third person comes, he does not eat any idli, he eats 2 vada. The fourth person comes, he eats 5 idlis, he does not eat any vada. Now, what is the relationship between big data and idli vada, if you ask me? You need to understand most of the algorithms, especially the greedy algorithms, they talk with respect to the space. What does it mean? So once I have this data, I can plot this data. On the x-axis, I can have idli. On the y-axis, I can have vada. So I can mark it 1, 2, 3, 4, 5. I'll also mark 1, 2, 3, 4, 5. The first person has eaten 2 idli and 1 vada. So on the x-axis, I come to 2 and 1 vada. This is the first data. The second person has eaten 3 idlis and has not eaten vada. My second data. The third person has eaten only 2 vadas. My fourth person has eaten only 5 idlis. Okay, this is my fourth person. Now, if I want to find the difference between person 2 and person 4, or between person 3 and person 2. Let us start with person 3 and person 4. So person 3 eats only vada. When it comes to the hotel, he eats only vada. Person 4 eats only idlis. So if you see the distance between these two people, if I look at the distance between these two people, it is extremely high. What is the distance? It is nothing but, the value is square root of idli is x. If I call idli as x, then x2 minus x1 or x1 minus x2, whatever it is. It is 5 minus 0 whole square plus 2 minus 0 whole square or 0 minus 2 whole square. 5 idlis, 0 vada. This chap is 0 idlis, 2 vada. So it is 0 minus 2 whole square. So what is the value I am getting? I am getting square root of 29. The distance between person 3 and person 4 is 29. Square root of 29. So square root of 29 will be about 5.2 or something. Let me write it as 5.2. Now, take the difference between the person, the people who have come to eat 1 and 2. 2 idlis, 3, 1 vada. This person is 3 idli, 1 vada. So square root of 2 minus 3 whole square plus 0, 1 minus 0 whole square. 2 minus 3 is 1. 1 minus 0 is 1. Square root of 2, which is 1.414. Can you see that the distance between 1 and 2, the distance between 1 and 2 is very close. 1 is here, 2 is here. The distance is only 1.414. Whereas the distance between 3 and 4 is root of 29, which is 5.2, approximately 5.2. Now, if I set a k value is 2, if I set k equals 2, I can very confidently state if the computed distance is less than 2, they are similar. If the computed distance is greater than 2, greater than or equal to 2, they are dissimilar. Do you agree with me? So what I have done is I have just plotted it. And I am able to show that the distance between 1 and 2 is very less. 2 idli, 1 vada, 3 idli, 0 vadas are almost in similar idea, eating style. But if a person comes and says, I want only vada, I don't want idli, and another person comes and says, I want 5 idlis, we see that the distance has increased. So this is a classic case how K nearest neighbor is used. This is a classic case how K nearest neighbor is used. Got it? So here I am talking with respect to 2 space. I am talking with respect to idli vada. So I was able to happily plot it in XY. I was happily able to plot it in. I was able to plot it in idli versus vada. If there was another parameter called as coffee, then that will come in the Z. X, Y, Z. So if the coffee consumption, if I said is 2 or something, then it is x1 minus x2 whole square plus square root of x1 minus x2 whole square plus y1 minus y2 whole square plus z1 minus z2 whole square. This is 3 dimensions. So you have length, breadth and height, something what you can imagine. But instead of that, if you have 5 dimensions, I have 5 variables, x1, x2, x3, x4, x5. Or I have 10 variables, x1, x2, x1, y, x, y, z, z1, z2, z3, z4, z5, z6, z7. Can you imagine that? Can you plot that? You will not be able to plot this in a graph. But the formula remains the same. x1 minus x2 whole square, square root of x1 minus x2 whole square plus y1 minus y2 whole square plus z1 minus z2 whole square. Z1 minus what z11 minus z12 whole square, z12 minus z21 whole square, something like that. Okay, so it keeps working. That is how your simple K nearest neighbor algorithm works. If I am able to work on this on the individual virtual machines, then this becomes a big data algorithm. This becomes a big data algorithm. Let us look at a second scenario. Let us look at a second scenario for the same idli vada example. Let me try plotting it. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So first person is having 2 idli, 0 vada, then 3 idli, 1 vada. Okay. We'll worry only about the first person. First and second person. The first person is having 2 idlis, so 1 comes here. The second person has 3 idlis and 1 vada. The person comes here. The third person had 0 idlis. Oh, what is it? So the third person has 0 idlis and 3 vadas. So he comes here. The third person. The fourth person has only 5 idlis. He comes here. Now, if I am able to draw a line which will separate my pure idli eaters from my pure vada eaters, this might be an error. This might be an error because this person has taken 3 idlis and 1 vada. So if I try to draw a line like this, then I can draw infinite number of lines. I can draw infinite number of lines. Here, if I draw like this, then I'm able to segregate my idli eaters and vada eaters. This is the foundation for support vector machine, where it talks about different class labels. I'm putting stars, like something like this, so that you have one line touching the star. You have another line which touches the other class, as in the class is here, and the center line that is drawn is called as the support vector line, which splits one class from the other class. The same algorithm can again be used in big data. So support vector machine also can be used as an algorithm in big data analysis. So I have my k nearest neighbor algorithm where we talk about multiple where we talk about with respect to multiple parameters. I showed with respect to idli and vada, but I can also talk with respect to not only with respect to idli and vada. I can talk with respect to idli, vada, coffee, and I can also talk with respect to idli, vada, coffee, tea, or idli, vada, dosa, whatever it is. There are n number of variables, and among this n number of variables, if I am able to find the distance, that means I am representing it as a matrix. I have the first tuple or the first data of person 1, I have data of person 2. It can be various variables. Instead of idli, vada, it can be age, gender, whatever it is. There can be hundreds of variables. This forms a matrix. I can find the distance, and based on the distance, I can set a rule which will help me in identifying whether a person, the people are of similar character or of different character. That is what my k nearest neighbor algorithm states, and that is what can be used in big data. And if that succeeds, the output is good. If the output is not good, go back to your data. Navy Bayes is a popular algorithm in big data algorithm, among big data algorithms. K nearest neighbor is extremely popular. Support vector machine is extremely popular. So K nearest neighbor is called as a distance based algorithm. Navy based is called as a probability based algorithm. Support vector machine as is a separate class of algorithm. Neural networks are a separate class of algorithms. Then you have your decision tree algorithms. Decision tree algorithms, whatever, whether you're talking of classification and regression tree, C4.5 or J48 or decision cart, they all work extremely well in big data algorithms. Absolutely not a problem. Okay. You can also go for ensemble. You can go for boosting algorithms, bagging algorithms. All will work extremely well in big data, among big data algorithms. You can also go in for your typical neural network, recurrent neural network. You don't have any problem. Jordan networks, anything you use, you don't have a problem. But the moment you talk of convolutional neural networks, you require extremely high amount of computational power. And that is where, it might, since it uses extensive amount of computational powers, it might perform better than your conventional algorithms. That is where you go for convolutional neural networks. It depends on the ReLU that you create. But again, convolutional neural networks might be pretty good with respect to image processing. But if it comes to sentiment analysis or opinion mining, if you ask me, the percentage difference improvement may not be very high unless the number of parameters that you're trying to capture is extremely high. Okay, so when we're talking with respect to big data algorithms, all the machine learning algorithms that you are using here typically can be used here. Only the workflow will change. When I say the workflow will change, you're talking of a huge amount of data that has to be processed. And when I'm talking of processing, I talk of identifying the missing values, imputing the missing values, identifying the outliers, eliminating the data or replacing the outliers, go in for do a statistical technique, testing, take a sample data if required. If you're if you're in the research stage, take a sample data. On the sample data, you do the descriptive statistics, measure the skewness, kurtosis. If the data is normal and not non-normal, you can go for feature selection techniques, identify the independence using covariance or Pearson's correlation coefficient, or if it is a normal data, if it is a non-normal data, go for Spearman's correlation. If it is categorical data, use a chi-square test, select the features. Once the features are selected, use simple techniques like k-nearest neighbor. So in the background, the data might run in Hadoop or Apache Spark. We are not bothered about it. If you get a good output, then you can be sure that the data is well cleaned. And this data can be taken forward for any amount of research. So now when you're doing a PhD, identifying a feature selection technique or identifying a classification algorithm is absolutely not important. It is important for your degree. But now if you want good outputs, you better ensure that the data is extremely clean, or else you are going to have problems. Any questions here?
Sir, can you say about nearest neighbor algorithm and k-means algorithm? What is the difference between these two?
Who is speaking? Sorry, can you tell me your name? I am not able to see.
Sir, you already say about k
No,
nearest
no.
neighbor algorithm.
Shivamani, right? Okay.
Yes, yes, sir, yes, sir.
Thanks, Shivamani. Yeah.
Sir, may I know about the difference between k-means algorithm and k nearest neighbor algorithm? How it works?
Good question. Very good. So you understood how K nearest neighbor algorithm works, right? I showed you the idli vada difference, right? That is for K nearest neighbor algorithm. We use the Euclidean distance formula. Did you understand that, Shivamani?
Yes, sir, I follow it.
Excellent. Excellent. Now, when we talk about machine learning, I think today morning somebody was talking about the college prediction where I said, no, go for a regression model. So, no, either I go for a regression model, I can go for a association model, no, association rule mining, that various components are available, time series mining. Then two important areas where a lot of work is happening is the supervised learning and the unsupervised learning. Supervised learning is the process where I train the algorithm, no, I train the algorithm giving a training data and I have a class label. That means I tell my algorithm, this person is 5 feet 3 inches, this person is wearing a earring, this person is having a long hair, this person is wearing a jeans. Is it a male or a female? I am asking it very specifically. Tell me, is it a male or a female? I am training the algorithm. This is the process of supervised learning where I have a class label or the dependent variable, a number of independent variables like your height, weight, earring, nose ring, long hair, short hair, jeans, wearing jeans or no, they're all independent variables. They are used to state the dependent variable which is a categorical variable stating whether the person is a male or a female. This is a supervised learning. In that, the most popular learning algorithm is the this thing, k nearest neighbor learning. One of the most popular, simplest algorithm is the k nearest neighbor algorithm. But think of a scenario, no, or if you have a, in your classroom, you have 100 students in the class. You tell the students, all the boys sit on the left hand side, all the girls sit on the right hand side. That means you are specifying a class label, boy, girl. Boys sit on the left, girls sit on the right. You are specifying a class label. Now, in unsupervised learning, the second type of learning is unsupervised learning. You can go to the class and state, boys and girls, please sit in groups. Okay, then what may happen is, or no, you say you form groups yourself. This is unsupervised learning. You are not telling it should be male, female. Then what might happen is all the tall boys and girls might sit together. All the short boys and short girls might sit together, or that is no, you are forming two clusters, which is not governed by gender but governed by height. Or you might convert that into 4 clusters where no tall boys separate one group, tall girls one group, short boys one group, short girls one group. Or it can become 8 clusters. Tall boys one group who have scored greater than 50 marks in the test. Tall boys, one group who have scored less than 50 marks in the test, less than or equal to 50 marks in the test. I have 8 groups. These are called as clusters. Now, for identification of clusters, k-means algorithm is a popular technique. So, if you want to compare between k nearest neighbor and k-means algorithm, k nearest neighbor algorithm works for supervised learning. K-means algorithm works for unsupervised learning. That also uses the distance formula. But what happens is I form a random initial cluster head seed. A cluster seed is formed. Randomly, I'll say all boys greater than 5 feet 6 inches, one cluster. All boys less than or equal to 5 feet 6 inches, another cluster. There again, I use the distance formula. This is how your basic k-means algorithm works. Okay, so k-means is used for unsupervised learning. KNN works for supervised learning. Shomini, is it clear? Is your doubt clear?
So yes, sir, but the k-means clustering algorithm occurred in empty clusters, sir. How will I solve this problem, sir?
No, how means I did not get you.
Sir, when I'm clustering this, when I'm using this algorithm k-means clustering, empty clusters can be occurred, sir. How will I solve this empty cluster problem?
N
Empty cluster, sir, empty clusters.
empty clusters can be occurred. So this is EMPTY. Are you talking of EM? No, empty means empty, EMPTY. Am I right?
Sir?
Hello?
Sir, so yes, sir.
No, when you
I
said
listen, sir.
I
So I'm listening, sir.
sorry?
Sir, I want to know about
No,
more
when you
information about empty clusters, sir. Sir, when I'm clustering by using k-means clustering algorithm, empty clusters can be occurred, sir. How will I solve this problem during clustering?
you need to set the cases accordingly.
Sir?
How many clusters did you set? Did you tune the parameters? What algorithm? No, what? So can you tell me what software you used? What is the data you used so that I can help you?
Sir, I have used UC repository datasets. Then I have used k-means clustering algorithm. But empty clusters can happen
You see what
while doing
is?
clustering.
Correct. It can definitely happen. What I used?
You mean algorithm, sir?
Hello. Yeah, no. What is the data set you used?
Sir, I pick data from UC repository, sir. It's a random data sets. N number of data sets available in UC repository, sir. So I pick one data sets and I apply it,
Data
sir.
set?
Sir?
Okay. So in one of the
For example,
clusters,
medicine
you
data
got
set, sir.
zero data. Medical, okay. You used a medical data set, fine. What was the medical data set? Did it have a class label or it was a pure clustering problem? Since you took it from UCI, the data set that you used, did it have class label or was it this thing?
So the data set is having a class label, sir.
It was having a class label. That is one reason why you would have got an empty cluster. Okay. See, when you are talking with respect to k-means clustering, when you talk of the class label not being used, that means there is no class label. Though it contains a class label, I am assuming when you use the clustering algorithm, the class label was not used. Now what happens is you take one variable and within that variable, I create a common point. I create random points. Okay, let us say I create two random points. I to create two random values. Okay, now let us say I have a variable which has values between 1 to 5. Okay, now I create two random variables between 1 to 5. Let me call it as 2 and 5. Now all the records which contain variables which is less than 3 or which lies between 1 to 3 will join the cluster 2. Join the cluster centroid 2. My other cluster centroid was 5. All the variables which are between 4 and 6 or 7 will join the cluster centroid 5. Did you get this? Let us say 1 to 10 data இருக்குன்னு வச்சுக்கோங்க. 1 2 3 4 5 6 7 8 9 10 இருக்குன்னு வச்சுக்கோங்க. கரெக்டா? இப்போ நான் ரெண்டு ரேண்டம் வேல்யூ எடுக்கிறேன் 1 to 10. நீங்களே சொல்லுங்க. Tell me some random values between 1 to 10. Tell me two random values between 1 to 10. Show me.
Yes, sir. I can say one random value, sir. So 1 1
Yeah.
2 1 4 3 5 4.
I'm having value between 1 to 10. Select two random values between 1 to 10.
Sir, only 2 random values, sir.
Only 2 random. I am talking only of 2 clusters, so I'll call only 2 random values. Yeah.
Okay, sir, 1, 2.
1 and 2 you are selecting. Okay, this is a classic example where you'll get zeros. Okay, so all the records with values of equal to 1 will fall under the cluster 1. Okay, all values which are greater than 1 will fall under the cluster 2. Do you agree with me?
Yes, sir, of course.
If there are no records with the value 1, if there are no records with the value 1, or if I set the k value as 2, then all the records with values 1 also can join the cluster 2, in which case I'll get cluster 1 as 0. You gave a random, I gave a random question, I gave a random value, you gave a random value, I'm able to prove that you can get 0 clusters. So this is a classic case of overfitting. இதெல்லாம் ரொம்ப கேர்ஃபுல்லா இருக்கணும். This will happen in imbalanced data. Regular data la இந்த பிரச்சனையா வராது. Imbalanced data la இந்த பிரச்சனை வரும். Am I clear?
Okay, sir, how will I solve this problem, sir? Can you able to say some idea about solving this problem?
No, unless I see the data set, it is very difficult to tell. Unless I see the data set, we need to logically identify, or see, and this you should also understand k-means clustering algorithm. The initial random solution selected, cluster node selected, cluster value selected is a non-deterministic polynomial problem. That is why we say if the data is highly imbalanced, k means algorithm will not work. We need to look at different algorithms, which can be something like where we look at optimizing the k value in the k-means algorithm. That is where you apply genetic algorithm or particle swarm optimization to find the optimal value of the initial random values that you select. But it also, one way to solve this problem is to increase the number of iterations. இங்கதான் நீங்க tools யூஸ் பண்றீங்க, வீக்காவோ ஆரோ பைத்தானோ யூஸ் பண்றீங்கன்னா there might be a default number of iterations where the convergence is not happening. You need to increase it and definitely you'll find a convergence happening. That is one way to solve the problem. The second way to solve the problem is use a heuristic algorithm, a greedy search algorithm, or a simple greedy search algorithm also to find the initial cluster values. These are the two ways you can solve the problem. Got it?
Okay, sir.
Okay, you can also come offline. You can talk to Dr. Geeta, you can collect my email ID and you can mail me, or we can connect offline also. புரியலனா சொல்லுங்க. கொஞ்சம் இது ஒரு காம்ப்ளிகேட்டடான क्वेश्चन கேட்டிருக்கிறது you have got this answer, but that is possible to obtain. It is possible to obtain that answer. Whatever you have stated, it is possible. Theoretically, it is possible. It will be possible in a highly imbalanced data. Any other questions? Anything related to your research, anything related to the work, or anywhere you have a doubt or something, if you can tell me, we can take it forward. Any questions? Yes, somebody want to ask a question? Okay, anyway, I think session will be slightly dry, more. It's more of you all to understand the concepts. If you don't have any questions, I think what's the time now? 3:42. Okay, I can call it. Any questions?
No, sir. I think no queries from participant side.
Okay, so shall we close it, madam? No,
Sir.
because it's 3:45.
Okay, sir.
Anything new? Thank you, madam. Anything else from my side?
No, sir. Shall I conclude, sir?
Yeah, please, madam. Thank you.
Okay, sir. Thank you, sir. Thank you for your informative and valuable session. And I thank all the participants for completing this today's session in successful manner. And also one kind information to the participants, feedback link is given in the chat box. So I request the participants to give the feedback